Hi everybody. This is going to be what I hope is a fairly short introduction to forces in one dimension. This is the Forces and Motion Simulation 2C, so it's session 2 and it belongs with the content information in C for session 2. So what I've done so far is I've done one of the first things it asks you to do when you get to this page, which is click on Graph Acceleration. So when you get there, you'll see this graph acceleration. What I've done is you are going to be asked to pick the file cabinet and the crate, and the objects are over here on the right hand side. I picked the refrigerator for the demonstration. Over here you could see some of the arrows we're going to be looking at. We can look here or we can look underneath the object itself. You're going to be asked to start out, first of all, you write down the mass of the object that you will choose, which is the file cabinet. And the first applied force we're asking you to use in this demonstration is 100. And so what we're going to do is once that 100 is in, we'll click go, and you'll notice a couple of things. Notice that the applied force is the same as the friction force. We don't have an exact number on this, but that's okay. We can see the arrows are the same. So the refrigerator is not moving even though we've applied 100 newtons of force. We're going to apply 200 and still no movement, although you see the forces have increased, and that's what we want. And over here you begin to see these arrows. Here's the force of acceleration and the force of, sorry, I just undid it by doing that. The force of acceleration and the force of friction. So we're pushing, in this example on the blue, from left to right, but there's a force of inertia and friction pushing back against us. And so we're going to continue to increase this until we see it move. So I can go by 100s, still not moving. It's a 400 kilogram refrigerator, so perhaps my hypothesis is when I apply 400 kilograms of force, it's going to move. Nope, poor guy's straining pretty hard. Still not moving. I can go up by 200s if I want. But there we go. There's 500. I keep going. I'm recording these. If you want to jump by 200s, you can. For the demonstration, I'm just going by 100s. A lot of force. Nope. I'm going to go to 1200. Still no. 1400. Nope. Okay, I think we left off at 1400. We're going to try 1800, 2000, 2200, 2400, 2600, okay, we're going to pick it up at 2800. Okay, so somewhere between 2600 and 2800 was enough applied force to get the refrigerator to move. So I'm going to go, I cleared mine, so I'm going to go straight to 2800 and I'm going to pause. We can't see all of these arrows over here, but we can see them underneath the refrigerator when we do 2800. So notice, I mean, it's off our scale, we can't see it, but the applied force has overcome the force of friction, and now we can move it. We may not be moving it very fast, but we're moving it. So that's essentially what this is about. This is the total force in this direction. Okay, I wanted to briefly show you something. So I cleared my graph of acceleration, and here's my applied force of 2600, and we already know that that does not make the refrigerator go. But we know that 2800 does. So when I click go here, suddenly I see an arrow that says total force in the movement direction. That's pretty much what this simulation is all about. We are asked to choose the file cabinet and the crate, but you can see that it takes much more than 200 kilograms or 300 kilograms to get it to move. We ask you to start with 100, but you can go up by 200s if you want, until you find as close as you can reasonably to the force that needs to be applied. Thanks, and I hope this helps explain this simulation.